So we first started off by drawing our person with the lawnmower pushing down at theta degrees. So that's normal force going downward. And then we broke that into components, the x and y component. And then there's force of friction going to the left. There's force of gravity going down and normal force from the ground going up. So for part B, we were trying to find the force of friction. So what we did was we did force of no, total force equals max and total force equals may. So F cosine theta minus FFK equals max. And we know max is going to equal 0 because there's no acceleration. So we could find out that the force of friction is going to be 88 cosine of 45 because theta is a 45-degree angle. So then force of friction is going to equal 68.2 newtons. For part C, we then tried to find the normal force going up. So we had to find the normal force going up and then the normal force of y also. So we did normal force equals F sine theta plus Fg. So it's 88 sine 45 plus 14 9.8, and then we got a total normal force of 199.43 newtons. And then for the last step, we were trying to find. So then in part D, we were trying to find the applied force. So what we did was we did F cosine theta minus FFK equals max. F cosine 45 minus 62.2 equals 14 times 0.6. So F of normal force of the person pushing down is going to be 99.88 newtons.
Okay. Okay, so for number 57, it asked first, so it told us that there was a pile of snow, a chunk of snow, on an angle, like going off the roof. And it first asked for what is the coefficient of the maximum static friction before it starts moving. So what we did is we found that we found that theta of Fg is here, and we found that the x was sine and the y was cosine because it's adjacent to the angle. So we did, for the x-axis, we did F sine theta minus the static friction, which is going the other way, like on our free body diagram, which equals max, which equals 0. And then for the y's, we did the normal force minus Fg times the cosine of theta, which is the y component, equals may, which also equals 0 because it's not moving. So to find the coefficient of static friction, it's normal friction force over normal force.
Yeah, I think so.
So then we did mu equals the normal force to find the normal force, since the y-axis is also 0. So the normal force equals Fg cosine theta. So we just plugged it in here. So like it would be mu equals Fg sine theta over Fg cosine theta. So it's friction force over normal force, because from here we saw that Fg sine theta equals the friction force. And so mu equals cosine theta over sine theta, which is the tangent of theta. And so mu equals the tangent of 30 degrees, which is 0.557. And now for the second part, it asks, that it says that it goes from a certain distance, and it asks for what is the final velocity after it goes a certain distance. So it's the same thing, except this time on the x-axis it has max, it's not 0. So we're solving for the acceleration in order to find the velocity. So I did Fg sine theta minus the friction force over the mass equals ax. And so the friction force is Fg times the cosine theta from here, as we saw before. And since Fg is mass times gravity, and mass times gravity, the masses cancel out. So it's just g of sine theta minus g of cosine theta times mu equals a. And then I solved for a, which, well, I plugged it into the equation first. So I did vf squared equals vi squared plus 2a delta d. So vf squared equals vi squared plus 2 times the 2 times g times the sine of theta minus g times the cosine of theta times mu times d, and then I plugged in all the numbers, and then I got 5.65. And then finally for the last part, it asks what is the final velocity after it falls. So I realized since it has an x velocity and a y velocity, so it must be a parabola and like kind of off the cliff problem. So I found the x component and the y component, and the x is vi cosine theta and the y is vi sine theta. And the final velocity from before would be the initial velocity times the sine of theta because we're solving for the y. And so vf squared equals vi squared plus 2a delta d. So vf squared equals vi sine theta squared plus 2a delta d, and plug in all the numbers and you get 13.77 meters per second.